Okay, so in this example, we're going to be talking about dividing radicals, and in particular, higher index radicals. So in the previous video, we were dividing square roots, where we know the index is 2, but in this case, our index is 3 on both of them, okay? So let's see how this is going to work out. So in this case, we need to rationalize the denominator, because remember, this won't simplify down to an integer, okay? So it's irrational, and we don't want to leave irrational numbers in the denominator. So we need to rationalize the denominator here. Okay, and again, we did this in the previous video with square roots. So let's go ahead and rewrite this. We have the cube root of 2 divided by the cube root of 3. Now here's the only difference. Notice my index. I want to get rid of that cube root on the bottom, so I need to multiply it by itself 3 times. Okay, when we were doing square roots, we only had to multiply it by itself 2 times. Notice my index. So it says 3, meaning I need to multiply it by itself 3 times. So for example, I'm going to do times the cube root of 3 times the cube root of 3. So 1, 2, 3. What happens now is this just becomes 3. Okay, so I have 3 on my denominator, and now I have to do the same thing on the numerator, so times the cube root of 3 times the cube root of 3. Okay, and now we want to go ahead and look at our numerator and look at our index. It's 3, 3, and 3. That's our confirmation that we can go ahead and combine these using multiplication. So I'm going to do 2 times 3, which is going to give us 6, okay, and then times 3 is 18. Okay, so we have the following. We're going to have the cube root of 18 all over 3, okay? So again, that is the index there. That's not a 3. Let's go ahead and make that a little smaller. So again, the cube root of 18 all over 3. So what we want to do now is simplify this down. Okay, so let's go ahead and just erase this part here. And what we want to do is look at our numerator and see if we can simplify it down. So the cube root of 18 using prime factorization, we get 6 and 3. Okay, and 3 and 2. So look here, I don't have 3 of the same number, meaning I can't pull anything out. So this here is going to be our final answer. Okay, so we have the cube root of 18 all over 3. All right. Okay, let's try our next example. So just erasing this. Okay. And we get the following. So we have the cube root of 4 all over the cube root of 3. So same thing, look at my index, it's 3. In order to get rid of this cube root of 3, because again, it doesn't simplify down to an integer, it's irrational, we need to multiply it by itself 3 times. So we're going to do the cube root of 3 times the cube root of 3. So we get 1, 2, 3, so it just reduces down to 3 now. Do the same thing on the numerator, so times the cube root of 3 times the cube root of 3. Okay, so again, our denominator now is just going to be simply 3. All right, and then our index is the same. We're doing multiplication, so we can go ahead and combine these using multiplication. So 4 times 3 is going to give us 12, right? And then times 3 is 36. So we get the cube root of 36. Okay. And now let's just see if we can break this down on the numerator. So I'm going to go ahead and erase this. So we have the cube root of 36. Just trying to break this down, we get 6 and 6, 3 and 2, 3 and 2. So if I'm looking at my prime factors now, I do not have 3 of the same number, so nothing can come out. So this here is going to be your final answer. Okay? So that is dividing radicals, and in particular, higher index radicals.